So I think I'll just introduce something to you here. Okay? Kung saan man tayo matapos, maybe by 12:20, then we will just continue it on Friday. Okay? So everything is okay with this what we call setup because Dr. Hison asked me to inform you about the changes that happened. And I keep hearing that. Kung meron lang magbibigay sa akin ng bato para maging Darna o manananggal, I'm willing to have a face-to-face thing. But it's really impossible for me to have a face-to-face session in class. And I was hoping that the other, what we call instrumental methods, should they decide the face-to-face. So I told them, all students who want face-to-face will go to that section, and all students who want to be online will attend my session. Okay, so the topic that I'm going to talk today is just, we could say, similar to the one that we have on the recorded lecture that I have posted. Okay, I'm going to post the link on that. Okay, so it has all something to do with sample prep. And the one that I'm going to talk today is the precursor for the so-called chromatography. Okay, so you cannot what we call perform chromatography without sample prep. So the solid phase extraction is a very useful method. We could say this is a sample preparation method prior to analysis. And if we're going to look at this sample prep, as we're going to look at this, is we're going to talk about why we're doing this, the approaches, the chromatography review and SPT strategies, some of the experiments that they have here, some method development guidelines, and troubleshooting tips. But we're not going to go all over them. I'm just going to get the most important part here. And I usually use these company slides of industry. Okay, Waters is an authority in chromatography. Some of the known chromatography are developed by these companies. And we have some UPLB alumni who are working in Waters. Okay, so usually when you do sample analysis, these are the biological samples from us, the food that we eat, okay, the industry around us, the environmental samples. So these are the samples that we use for analysis. And we could say, if we can analyze them directly, it's okay, right? Would it be nice if you didn't have to prepare samples before injection into the instrument? What does it mean? You inject it as it is. Okay? But the problem is, it's not possible. You have to do some sample prep. Okay? Why? Well, there are particulates that will limit the instrument or the system uptime. You can have what we call the plugging that can happen if you don't do sample prep. Okay. And whenever we analyze, usually the one that we analyze or the analyte that we analyze is not really the major constituent in the samples that we have. And these other samples, okay, that we call that made up this complex sample matrix, they can complicate our analytical result. Most of them may reduce the instrument system timeout. Okay, most of them will interfere with the signal that will come up from the analysis. So in most instances, the signal from the target analyte that we have are usually reduced. And in some times, they can be what we call enhanced. It depends. Okay? So for instance, if you didn't do any sample prep, these are the peaks that will come out. Okay. And of all of these peaks, maybe the one that I'm interested is just a very small peak on this side here. Okay. You're not interested in all of the peaks here. So that's what happens if you inject your sample without doing sample preparation. There are a lot of peaks that come out, and most of these peaks you're not interested in. So you're just wasting your time if you're not going to do sample preparation. Okay. So for instance, it's only need to analyze, let's say, this peak. But if you're going to look at this one, so this is what? From 5 minutes to 45 minutes, there's a lot of other peaks that come out. Okay. And the only one that you need is that peak at 15 seconds here. Okay. And that peak at 20 seconds. So you don't need those peaks there. So to do that, you need to do some sample preparation. Okay. Because if you're not going to do that, some of these other compounds would cause an increased downtime in your mass spec or problems in your column. Okay. Any idea of you what a column is? Is it the first time you hear the word column? May orgo na kayo, di ba? Orgo is organic chemistry. I don't know if that's the term that you use there. So may idea ba kayo kung ano yung column? Okay? So sa column chromatography, ano usually yung column? Anong phase siya? So usually if you're going to look at the column is where separation takes place. So in a column chromatography, you put there some materials that serve as your stationary phase, and then you pass by through the column your sample that contains the mobile phase. So your mobile phase is usually the solvent. So you pass the solvent there. There is an interaction of the materials that you have in the sample with the mobile phase and the stationary phase, and that's where separation takes place. Okay. Now, if you don't do sample preparation, all of those unnecessary compounds in your sample will pass through the column. And if you're using mass spec, that is usually the detector that can what we call cause increased downtime. Okay, so for instance, if you do a solid phase extraction cleanup, there is an improvement in the analysis. So without any cleanup, if you could see there, that's the red thing there, that's the sample matrix. Okay, but if you're going to do some solid phase extraction cleanup, you could see some of the peaks there, okay, are removed, and you have a much better blank sample matrix. And if you spike your sample, I mean, the only one that will come out there is the one that you're looking for. So without any spike here, so you could see some other peaks coming from your sample matrix. So the SPE removes those interferences or signals coming from the sample matrix. Okay. So that's what one effect is. So for instance, in one study that they use, when they use OASIS MCX SPE method, so you can find this one. And if you use another method, okay, you can find it in this way. So which one is a better method? The first one or the second one? Method A or method B? Okay, so as you could see here, there are more peaks in method A. Okay, so a much better method between the two is method B. So SPE is the one that was used. Both of them use what we call SPE. Okay, But as you could see here, you have a better what we call results from this one compared to that one. We could say it's more what? Clean. Okay. Now, another thing why you need to do this sample prep, we could say improvement of sensitivity. So the analyte concentration in your original sample matrix, usually they're too low to measure by instrument. And this will result to this so-called ion suppression. And to give you an idea how it looked like, so sometimes if you don't do sample cleanup or solid phase extraction, this is what you can see. And it's so low. And it's very difficult to quantitate them. The sensitivity is so low. But if you're going to use an SPE, like the one that you have here, as you could see, okay, there is an improvement in the sensitivity compared to the original one. So when you do this solid phase extraction, what it do it concentrate your sample to the point that you can detect it, to the point that the sensitivity improve. Okay, so that's one of the reason why you need to do this sample cleanup or sample prep, which in this case is solid phase extraction. Okay, so the way that it's going to impact you, the reading that you have, you're going to have acceptable response similar to the standards that you have in aqueous solution. So for instance, the example that we have there, what can happen to the analyte in a complex sample matrix? Okay, so if you just do the sample prep of protein precipitation, ito lang yung makikita mo. What can you say about this? You don't see the one that has 260, 291.1, and 411. Okay. So if you scan it, there's a lot of loss. Okay, compared to the one wherein you have an analyte standards in aqueous solution. So protein precipitation is another way of what we call sample preparation. Okay, so you can use different sample preparation techniques and it will give you different results. So for instance, in protein precipitation, there's an 80% ion suppression. Masyadong malaki yung loss. Okay? But if you're going to use SPE instead of protein precipitation, you could see that there's minimal ion suppression. So different techniques or different sample prep method, different results. So SPE is much better, let's say, compared to protein precipitation. Okay, so there's no loss in signal observed for analytes when the interference which caused the suppression are removed by SPE. So we can say that's one advantage that you have if you use SPE. Okay, so if we're going to look at the summary of the needs, when we do sample matrix cleanup, we improve the baseline interferences. So there's less baseline interferences from the matrix, and we reduce the ion suppression in mass spec. Okay, so if you're going to use the analyte pre-concentration, the processing steps needed to get the sample ready before injecting into the instrument. So you can use it in this different system. The example that we gave you is the LCMS and GCM. I mean, the one that is, this is useful is if you have the mass spec, because mass spec is, we could say, the standards of analysis at this time. But what's the problem with mass spec? Especially for a third world country like us. Anong problema sa mass spec? Mahal. But you know, you have, may mass spec na ba tayo dyan? What have you heard? For those who are already in UP Los Baños, there's a mass spec somewhere there in, is that APEC? yung malapit sa NCPC tsaka Biotech. Okay? Or anyone working here with Dr. Completo or Dr. Nacario? Meron ba dito nagtitesis with Dr. Completo and Dr. Nacario? I think they have a mass spec system. No idea. Okay. So the thing with mass spec is expensive and usually hard to maintain. Okay. Now you may ask yourself, why do we need to do sample prep? Bakit hindi na lang i-inject? Right? Why need to do this thing? So the slide here tell us the goals of sample preparation. One way is you're going to remove interferences for. Remember, the sample that you have are usually complicated. And when we're talking about complicated sample, the target analyte that we are looking for is usually present in minor constituent. Okay, so there's a lot other major components that is present there, and it would interfere in the signal of our target analyte. But if we're going to use sample prep, we remove the interferences. So if we use chromatography to analyze it, we have a better chromatographic results. We are more confident with the analytical results that we have. Okay, and if we remove the interference there, we make the lifetime of the column longer, because instead of 100 components passing through the column, by removing some of them, maybe only around 10 pass through the column, so the column don't get overloaded. So you can have a longer what we call lifetime of the column. And then there's what we call less instrument downtime. Instead of seeing 100 peaks, you might just seeing around 5 to 10 peaks, okay, which makes it shorter downtime. Now another thing why we do sample prep is we enrich the sample. So imagine you have what, 1 liter of the sample compared to 10 ml. Okay, so 10 ml, you're not going to detect anything. But if you have 1 liter, so that is how many times then the compound that you're looking for in 10 ml. Ilang times yung 1 liter sa 10 ml? Anyone? Is that 100 times? So if you have that 100 times of amount of your target analyte, so what you do, if you pass it through the SPE, it will be concentrated there. So when you inject it, you have a higher amount or higher load of your target analyte, let's say, than the one that just that you use 10 ml sample. Okay. And then another goal of sample prep, to make the sample more compatible for separation and detection. Among all the things that we have, I think there's a lot of sample prep if it's chromatography and mass spec. And how reliable your result is depends on the sample prep. Okay, so to make sample more compatible for separation, that's the LC or GC or CE, and detection, and one of the detection is mass spec. Okay, when you use sample prep, you can match the solvent strength. Okay, and you can eliminate the ion suppression that you can observe in LCMS analysis. Yeah, most of the analytes and compounds are affected by ion suppression. Okay, but others, there's what we call enhanced compared to what we call suppressed. Dependent yan doon sa analyte na tinitingnan mo. So whenever you want to analyze something, you really have to look at the history or literature what's the effect? Okay? Doon sa sample prep na ginawa mo. Because there will always be a result that some signals are enhanced and some signals are suppressed, okay, by matrix effect. Now, the ultimate goal, you do sample preparation in your analytical lab more productive, you lower the limits of detection, okay, you run more samples with less time, and you minimize the cost in manpower and equipment maintenance. So that's, we could say, the ultimate goal that we have. Okay. Now, if we're going to look at the sample preparation, I think that's the most time-consuming step. And typically, this is the most difficult. You have to find, or sometimes you have to develop a sample preparation method, and it's a case-to-case basis. Okay. One sample preparation or solid phase extraction may work on one analyte, but it may not work on another analyte. And typically, the least amount of effort spent developing a rugged sample preparation method. There's no magical method here. Okay. Just to inform you, my PhD thesis is mostly on sample preparation. And unluckily for me, the compound or the analyte that I try to develop a sample preparation method is one that always changes when you expose it to light, when you change it into pH, when it interacts with the environmental stuff. So it keeps changing. Parang hunyango yung analyte na ginamit ko. Okay? So if you're going to look at the sample prep, okay, the approaches that we have, so you can use the simple one. If you have a solid, you can have the filter or centrifuge. Okay. So you're familiar with filtration, right? And centrifugation. So we could say that's the what we call common thing that we have. So these are filters. We call it the syringe filters. Okay. So you're going to pass through some of your sample there, and you're just going to collect the one that you're looking for. So some other solids will what we call the remain in your filter. Now this one, you use it for environmental samples. I know ASL lab has that equipment. I have this equipment in my lab. Okay. Or you can also have what we call the filter plates. Yung tawag nating microplate as some of the filters. So these are common to separate the solid from the liquid. And then we can also have the so-called centrifugation. Okay. So if you have what we call your centrifugation, so you can have a device that's smaller like this, or you can have the so-called refrigerated centrifuge. I think in my video, in one of the rooms that I showed you, there's a big centrifuge there, a refrigerated centrifuge. So the way that you're going to look at the centrifuge, you look at this centrifugal force, okay? So it will let all your solids settle at the bottom. So that's the principle that you have here. Now, in terms of chemical, so ito yung mas related doon sa materials natin. Okay? So we can have the precipitation, liquid-liquid extraction, and solid phase extraction. All of them taking advantage of what? Ano yung principle behind dito? Anyone? One word? Solubility. Okay? So all of these chemical techniques that we have there, they take advantage of the solubility. Okay? Precipitation takes advantage of the solubility. Liquid-liquid extraction, it takes advantage of the solubility of your target analyte doon sa dalawang liquid phase of different polarity. Okay? Anong liquid-liquid extraction ang nagawa nyo or alam nyo? Anyone? What you did in 43-44? Anong tawag doon? Anong tawag yung parang ganito yung itsura? Ay, hindi ko ma-draw. Yung tapos magaganyan-ganyan ka. Tapos bubuksan mo. Okay? Yung separatory funnel. Okay? That is a liquid-liquid extraction. And how do you improve yung separation nila? Meron kang minsan dinadagdag na salt. Anong tawag sa process na yun? Salting out. So what you do here is you just add you some salt there. So ang mangyayari doon, magiging saturated yung polar component mo, mas maganda yung separation nila. Okay? So liquid-liquid extraction is still based on solubility. Ang differential lang, meron kang dalawang component of different polarity. So depende dun sa sample mo, pupunta yung isa sa non-polar layer or sa polar layer. Depende doon sa sample mo. Now the solid liquid extraction is different because there's a solid. Okay? So dyan sa solid na yan, mag-absorb or magpa-partition yung target analyte mo. But there are other chemical techniques. So you have dialysis and ultrafiltration that is usually used in biochemistry there. When I was doing my MS thesis there in biochem lab, I use dialysis so that I can get the protein that I have after precipitation. Okay, you can use electrophoresis. Okay, and then distillation and evaporation that is being done in organic chemistry, taking advantage on the difference in the boiling point or vapor pressure. Dialysis, ultrafiltration, yun yung tinatawag nating molecular weight or size. I think the concept that you have here is osmotic pressure. Okay, so electrophoresis, yung negative but positively charged. So usually you do this in proteins and amino acids. And then the supercritical fluid extraction. Okay, so you use here usually carbon dioxide. So this is the principle behind what? In our everyday life. Saan ginagamit tong technique na to? Sa everyday life natin. Anyone? Supercritical fluid extraction. Are you familiar with dry cleaning? Familiar kayo sa dry cleaning? Why do you call it dry cleaning? Anyone? Huh? Why do you call it dry cleaning? Come on! Kasi hindi kayo gumagamit ng water. Tama. Right? Just like what dry ice is. Ano bang dry ice? Wala ring water. It's CO2. Okay, so the same thing in dry cleaning. So the principle in dry cleaning is a supercritical fluid. Okay? So what it did is you have a supercritical component or supercritical fluid material. So at supercritical fluid, you cannot liquefy your sample even if you apply pressure. So it is in this supercritical state. So at a supercritical state, it will dissolve the dirt that you have in your clothes. Okay, that's doing this so-called dry cleaning. Supercritical fluid extraction, that's also the one that they use to remove caffeine from coffee. Kaya meron kang decaf. Because kung hindi mo gagawin yun, ang pangalis ng caffeine use of non-polar solvent. Okay? So we will end the discussion about this thing here, and then we will continue on this on what we call Friday, so that I'll give you time to answer the question for your quiz. So if you're going to look at the control chart that I gave you, so just to make sure. So you got this, class?
Yes po, sir.
Yes
Yes
po.
po.
Nakuha niyo to? So what I'm going to ask you to do, you don't need to submit this thing. So what I ask you to do is to summarize what we're going to do, okay, sa data ninyo for each day. So that you could put there day 1 to 20. So based on the things that you have here, so this is the mean, this is 1 standard deviation, 2 standard deviation, and 3 standard deviation. So if you're going to look at this, anong gagawin mo dyan? Reject, retain, warning. Reject, return, warning. Reject, return, warning. Okay? So that's the first set. Now, the next set, for those days na merong warning or reject, ano yung error na yon? So yun yung ano, mga 21S, 24S, 22S, some sort of that. So ilalagay nyo doon sa time na yon. And I'm giving you until 1 o'clock to submit it. Clear ba?
Yes po.
Yes, sir.
Yes po. Sir,
Pagka-
tanong ko na lang din po. Kasi dun po sa legend, yung yellow broken line is S and 3S po yung nakalagay. 2S ba po talaga dapat yun?
Teka lang. Saan? Sa...
Yung legend po kasi, yung yellow na
ang
broken
legend
line.
usually ito, 3S. So ito yun. Yung black.
Opo, yung yellow broken lines po, dapat po ba 2S both yun?
Yellow ba to? Kasi parang orange sa akin
Ay,
eh.
yung orange po pala.
Oo, yung broken orange is two significant standard deviation, the upper
Thank
and
you
the
po.
lower limit. Tapos yung blue ay yung standard deviation. So yung straight line na orange, yun yung mean. So ito yung sample control chart. Okay, I make the control chart on its own. So based on the data that you have there for each day, you decide, are you going to retain, reject, or warn the data that you have? So you can, what we call, you don't need to type written it, handwritten is fine because wala kayong time. I don't want you to spend. Okay, so what you're going to do is just, we could say, answer it by writing the answer that you have. Okay, and then take a photo. And then what we call the submit it. Okay. So question.
Sir, okay lang po bang i-type na lang po sa MS Word?
Bahala kayo. But you need to submit it by what we call 1 p.m. Bakit? Parang kahig ng manok ba yung sulat nyo? So question. Parang meron nag-exchange ng chat. Yes, Mia.
Sir, kailan po ulit yung module quiz for chapter?
Most likely it will be next week. Kasi nga, yung
Tapos,
event doon sa Paase, and I cannot say no. So I might schedule it on that Tuesday time because ang alternative ko is for you to watch that event, but Dr. Completo told me that you need to register at ang i-consider ng nila yung first 100 registrant. Okay? So ang
so
ano ko
hindi
sana,
pa po magmo-module 3 na quiz.
nagmo-module 3 na tayo ngayon.
Hindi. I mean, yung chapter quiz po ng module 3, hindi pa po siya next week.
So module 2 tayo, yung whole chapter 2 na quiz ng Module 2 or Chapter 2 quiz tayo next week. So
Ay, sige po. Thank you
nag-forward
po.
na ako ngayon. Okay? Clear ba yun?
Opo, thank you po.
May tanong pa?